Today's video is going to focus on two different lessons guided notes, lesson 8.4 and lesson 8.6. I want to take a look at the word problems from these two lessons, including word problems on volume and some word problems or a word problem on surface area. So I want to begin with the lesson 8.4 guided notes. We're going to begin with questions 9 and 10, the word problems for volume. So let's read through question number 9. Number 9 says, an aquarium is being constructed so that it will be a rectangular prism with a length of 8 feet and a width of 5 feet. If the aquarium is to hold 220 cubic feet of water, what should be the height of the aquarium? So first of all, we know that this shape is a rectangular prism. We also know that it has a length of 8 feet and a width of 5 feet. And we know that the aquarium is going to hold 220 cubic feet of water. That tells us, by the way, that the 220 cubic feet is going to represent our volume because it's the amount of water the aquarium will hold, plus the label is in cubic feet, which indicates volume. What we're trying to find here is the height of the aquarium. Since this aquarium happens to be a rectangular prism, we're going to use the volume formula for a rectangular prism, which is length times width times height. Let's plug in what we know. We know the volume is 220. We know the length is 8. We know the width is 5. So we have 220 equals 8 times 5 times the height h. 8 times 5 is 40. We solve this one-step equation by dividing both sides by 40 to get a height of 5 feet. Again, since it's just a dimension, we're not going to put cubic feet. It's just going to be 5 feet, meaning this aquarium, fairly large aquarium, is going to be 5 feet high or 5 feet tall. Let's take a look at number 10. So number 10 is very similar to number 9. So if you want to try one of these on your own, number 10 would be a good problem to try. It says, a children's rectangular pool holds 960 cubic feet of water. What is the depth of the pool if the length is 30 feet and the width is 16 feet? Once again, in this problem, we're talking about a rectangular pool, and it's three-dimensional, so we're talking about a rectangular prism. We know that it holds 960 cubic feet of water. That tells us that 960 is our volume. So we'll label that right above it. So this is our volume. It asks us to find the depth of the pool. If we know that the length is 30 feet and the width is 16 feet. So we're going to use the same formula as we did for number 9, which is length times width times height. So if I know that the volume, oops, we moved that. If we know that the volume is 960, we replace V with 960. The length is 30, the width is 16. 30 times 16 gets us 480. We solve this one-step equation by dividing both sides by 480 to get 2 feet for the height or depth of the pool. So we use the word depth in this case, and you might think, well, is that the length, width, height, volume? Depth is just another way to represent the height of something. Because we're going underground, we call it the depth. So in this problem, it will be 2 feet. All right, let's take a look at number 11. So number 11 is a good problem because it deals with the similar type of situation to the previous two. You can certainly try this one on your own. It's up to you. So in number 11, it says a mini fridge has a volume of 9,504 cubic inches. So we are given a volume of 9,504. It measures 45 inches high by 22 inches wide. We want to find the depth of the mini fridge. Now, it's not telling us what kind of shape this is, although we can kind of assume that it's probably going to be a rectangular prism, just because that's typically the shape of a fridge. In addition, we are given the height and the width of this. We're typically going to be talking about a rectangular prism in that case. So we're going to use the same formula that we did for the previous two questions. Volume is 9,504, our width is 22, and our height is 45. So we'll replace W with 22, H with 45. It doesn't matter that we're trying to find L. It really doesn't matter which variable we're looking for, either length, width, or height. It does say find the depth. In this case, the depth is going to be the length of this thing. Whether it's LW or H, it really doesn't matter. Same work. 22 times 45 is 990. Solve this one-step equation by dividing both sides by 990, and you get that the length or depth of this mini fridge will be 9.6 inches. Okay, one last problem is a multiple choice question. Number 12 says, a rectangular prism has a volume of 5,280 cubic inches. It has a height of 4 inches. Which of the following could be possible dimensions of the base, meaning the length and width? So once again, we know we're talking about a rectangular prism, so we're going to use that same formula. We also know that it has a volume of 5,280 cubic inches, and we know that the height is 4 inches. So what I did for this problem is I used the same formula as the previous problems. I replaced V with 5,280 and H with 4. I divide both sides by 4 to get length times width by itself. So what I know in this step right here is that my length and width need to multiply to get me 1,320. So I go through my 4 answer choices. Let's start with A. If this is my length, this is my width, and I take 4 times 1,320, I know for a fact that that's not going to get me 1,320. So I can eliminate that choice because it doesn't make sense. So let's go to choice B. If I take 44 times 30, what does that get me? It's going to get me 1,320. I want length times width to get me 1,320. It tells me then that choice B is the correct solution. I could do 40 times 132, 40 times 50, but neither product is going to give me 1,320. So these two could also be eliminated. That's a tough problem, but I think it's good to get us thinking about how to apply this information and also determine what could possible dimensions of the base be. Okay, I want to see one last word problem from the lesson 8.0.